Hello everyone and welcome. Thank you all for attending this Security Innovation Europe webinar entitled Secure by Default Application Architecture. My name is Mark Dunlop, your host, and I'm here with Stephen de Vries, who will be doing the demonstration today. So before we start, some quick housekeeping. Can I ask that you put all your microphones and handsets on mute so that the webinar is not interrupted by any background distractions. Also, there will be a Q&A at the end, so please use the chat function to send us your questions, and if there's time, we'll include them at the end of the webinar. This webinar will be recorded and made available at a later date for you to review again. The agenda for today is to provide you with an overview of how you can attain secure by default applications using a risk management framework of tools, processes, and practices to deliver applications which are security appropriate, followed by a demonstration of some key areas of this approach. So let's get started. The challenge in creating secure by default applications firstly lies in the ability to understand all the potential threats to our applications. And from that, creating a detailed set of requirements, together with the countermeasures needed, and then to manage them throughout the software development lifecycle. And at every stage, then to have a central oversight and input into all these activities and progress, as well as providing immediate information on inherent, current, and projected risk of your applications. There are 4 components for a secure by default application: threat modeling, risk review, countermeasure progress, control and reporting. This structure then manages the whole end-to-end process and ensures your application security is fit for purpose. In our end-to-end process, let's start with threat modeling. This is usually done using high-level modeling tools, which then needs to be converted into a set of requirements for development to deliver against. As we all know, creating these requirements currently depends on the skills and knowledge of people, which may or may not be up to date or even complete, which lets threats to be inadvertently introduced. In addition, there are standards which you may need to meet, industry regulations, and even your own standards, which you want to incorporate into this. So these activities, as you know, are very resource intensive and are indeed the most challenging to deliver the necessary detail to achieve appropriately secure applications. Today, we'll show you the generation of a detailed threat model using architectural risk patterns, together with the generation of countermeasures, standards, and so on, which can be delivered in minutes rather than the traditional days or even weeks of effort. With detailed and fit-for-purpose requirements, countermeasures, as well as your own regulatory or industry standards applied, these are then sent to your developer requirements management tool of choice to start their developing. Today, we'll also show you this in practice and how risk is managed and communicated to security champions and others. As most developers are not security experts, there's also a need to be a way of supporting them with security knowledge and indeed relevant code snippets to support them in writing quality secure code first time. Not having this keeps you in the leap of rework, cost, and the associated time penalties. Output from your code scanning tools also needs to be managed, and test results to be gathered to make sure the countermeasure progress and risk status is complete, all to be imported into a single place. With all this information accessible in a single location, provides a risk management framework of tools, processes, and practices to deliver applications which are security appropriate, and delivers management with information about their applications in terms of progress, risk profiles, It enables security champions to be able to have full access to all areas of the life cycle and input and influence on that. And it provides the developers with the tools and resources they need in order to get the application code correctly written first time. So I'll now pass over to Stephen to provide you with a demonstration on the generation of threat models and countermeasures using architectural risk patterns. And because of time, we'll look also to how countermeasures are managed within one of our examples, which is Jira. And we're happy to answer any questions on any of those other elements at the Q&A session. So let me just pass over to Stephen de Vries. Stephen?
Hi, good afternoon all. So the primary user that we're targeting with the SRA application is the security team. Developers themselves and architects can also use the tool to input information, but the user who's going to get the most benefit out of it and who's going to drive the majority of the actions will be a member of the security team. So I'm going to walk through a typical example of what the security team member will do when they onboard an application and how they will then communicate the security requirements to the development team, and also how the testing will integrate with those requirements. So there are a number of configuration and setup steps you can do before you start using the application. I'll skip over those and comment on them as we move through a real-world demonstration. So let's assume we're starting with a new application. In our terminology, we call this a product. So a product can be an environment. It can be an environment plus an application or something that's going to be built. So I click on New Product, and I can enter the name of the application here. So let's say this is going to be a consumer banking web app, cons banking, and I can enter some tags, I can enter a description, and as part of the initial configuration, you can also define your own custom fields that you would like to appear on this, this initial form. So you can define fields for the risk owner, the business owner, the date it was last tested, any kind of additional information that you want to capture for that product can be added to this form over here. So I'll click on Save. And now we get our first questionnaire. So questionnaires are a key part of SRA. We believe that this is a really cost-effective way of scaling application and particularly architectural security. If we want to streamline this process, then questionnaires really help us to reach a larger audience and make it easy enough for developers and architects to define the architecture via a questionnaire. So the first questionnaire asks us for a selection of components. So if we're going to build this application, we can say that it's going to contain a web application on the server side, and it's going to contain a data store. And as I click on data store, we get a new category here where we need to select the type of data store. So this question is the first part, or one of the elements that is customizable. All of the questions in this questionnaire, as well as all of the categories that appear at the top of the questionnaire, are 100% customizable. What's more, you can also customize the behavior of the questionnaire. So when a user clicks on question X, you can cause a new category to appear and ask them more questions about whatever X means to you. What you're seeing now is our default data set. So this is the data that we provide as a default when you buy the solution, but you can of course change it after the fact and adjust it to what you want to see in your environments. Okay, so I've selected two components. I click on Done, and now we get more detailed questionnaires for each of those components. So the first component here is the PostgreSQL database. And I'll just change the name here for customer data. It will ask us how are we going to authenticate to the data store component. In other words, how is the web application going to authenticate itself to the data store? We can choose something like Microsoft Integrated or username and password. We need to choose which trust zone this component is going to be deployed in. So these trust zones, again, are configurable within the SRA environment. So you would, at install time, predefine a set of logical security zones that correspond to the same level of trust for each zone. What the user doesn't see here is that each of these is linked to a numeric rating for how much you trust that zone. And we will use that rating to influence the risk score for any threats that are identified and associated with this component. So let's say, for example, that this Postgres database is on some private secured trust zone, which means something specific to my business here. That's a secured zone within a trusted private zone. And similarly for the assets. So these data assets, by default, you see 3 data assets here. This is just for this demonstration, but you would, at configuration time, configure your own data assets that are in use within your organization, and you would insert a classification for each of those data assets, indicating how important is confidentiality, integrity, and availability for those assets. So in this case, we can say that we're just storing customer data, and let's say we're sending it and receiving customer data. Deployment, we can choose different deployment models, either internal or on the cloud, and we can choose how we're going to encrypt the communication between the other components and this database component. So none of these questions are mandatory, which means that the user at any point can click done. This works particularly well in agile environments where you may know some of the information up front, but not necessarily all of it. So you can hit done at any point. It will generate a model, and you can then revisit that model to add new information when the information becomes available. So I'll click done there. And now we get the same type of questionnaire, but this time for another component. This time it's the web application. So let's just call this the Cust Banking web application. And that will be its logical name. And the type of questions that we'll answer now are going to be different because these are applicable to a web application. So we can answer things like the type of web server it's going to be. Let's say it's Tomcat. How are we going to implement authentication? So if this was a development team building a new authentication system, they could say, yes, we're going to create a new authentication system, and then we will ask them more relevant information here. So just to reiterate that this behavior of clicking on a question and asking more detailed questions is 100% customizable by the operators of the system. So you can create your own question groups, and you can create your own Boolean logic that determines which questions appear when. So what we've done here, for example, is we're only displaying this for web applications and web servers. We're not displaying this for databases because it's unlikely anybody's going to build a new authentication system for a database. We can also communicate to the user as they're completing this system. So if you did want to expose these questionnaires to architects and developers, you can build in warnings. So for example, here we've effectively given them almost a honeypot by saying that we will reset the password by emailing out an existing password. And if they select that, we will pop up a warning saying, this is a bad idea, reconsider what you want to do with this option here. So you can use this to create warnings, you can create error messages as well, and you can even disable the done button. So you can say, because you've chosen X, Y, and Z, it indicates that this is a paradox. You can't possibly have this type of architecture, and we'll block the questionnaire until you correct it. And so the user will continue with these questions. I'll just answer a few here. Let's say that in this case, we are processing credit card data. So we have a built-in rule that says as soon as the user answers processing credit card data, ask them more details about that data, because now we fall under the remit of PCI. So they can say that we are storing or processing the PAN. Deployment, again, we can deploy to different environments. Session management, data transport, user registration, features. So as you can see, for a component that you are going to put development effort into, like a web service or web application, the user has many more questions that they should answer about it, because there are many more opportunities for them to get the design wrong of that application. And languages and frameworks. So once the user has finished this application or finished this questionnaire, they can click on Done. At this point, SRA has automatically generated a threat model for both of those components. So we've created a threat model for the Postgres database and one for the customer banking web application. If you wanted to, you could now skip this window and go and directly view this threat model. But this window and the one following it are really part of this workflow of very quickly onboarding an application. Since we've got this threat model, the model now already has 48 countermeasures that are in the recommended state. So since the default data set doesn't know what you require as requirements in your environments, it marks everything as a recommendation by default. If you wanted to turn those into requirements, the easiest way to do it is to just apply a blanket standard. So we can apply the ASBS level 1 standard, and we'll turn 19 of those recommendations into requirements. If we apply level 2, we'll turn 32 of them. And if we turn PCI DSS, we'll turn 33 of them into requirements. So all this does is just flip the state of the countermeasure from a recommendation into a requirement. To keep it manageable, I'm just going to list OWASP ASBS level 1, apply the standards. It's now turned 21 of them into requirements. There were some duplicates in there. And again, this window is optional. It's just purely to streamline the workflow and to say to the user, well, now that you've got 21 requirements, why not upload them directly to an issue tracker? So we support Jira, Redmine, TFS, as well as ServiceNow. So we have a pre-populated configuration for Jira, our own Jira test instance, and all the user has to enter is the name of the existing project on Jira where they're already managing their functional and non-functional requirements. So I'm just going to enter the key here, and I can choose upload. So at this point, if you wanted to go extremely fast without even reviewing manually the auto-generated threat model, that is the way you can do it. You can follow the questionnaire, apply a security standard, and automatically upload those security requirements that are required by that standard directly to the Jira project of the users. So as a security team, you can now go and refine that auto-generated model because it may not be 100% what you're looking for. So firstly, you can have a look at the architecture. And on this architecture tab, we can see that we have a Postgres for customer component here. And then we also have a customer banking web application, which is located on the Internet Trust Zone. We can add new components. So as new components are added to the architecture, we can add them here. We can edit existing components, and we can go and modify the questionnaires that we've added there. A nice feature is that if you do have diagrams of the architecture, you can simply add them to this page here, and you can see the diagrams alongside the application just to keep track of what is going on in the design of the application. The threat model itself is viewed through the Threats tab. And what we'll see here is the two major components, so our banking web application as well as our database. Each of these have a set of threats associated with them. And looking at this example here, we have a threat that anonymous users could gain access to sensitive data. We can see that our risk response is that we do plan to mitigate this 100%. Currently, we have made no progress in doing so, and our current risk rating is regarded as critical. So this risk rating is derived from the value of the data that we're dealing with on this component, as the user has indicated in the questionnaire, as well as the trust zone where this is going to be deployed, and also the impact of this particular technical threat in the system. Looking at the bottom half of the screen, we can see a tree structure that shows us what are the likely weaknesses that are associated with this threat. So in this case, we have two weaknesses: reliance on a single factor and missing authentication for critical function. For this particular weakness, we have two countermeasures that are both marked as requirements. You can see that apply two-factor authentication is marked as a recommendation because it did not fall under the remit of the OWASP ASBS level 1 standard that we applied. Nevertheless, if we don't agree with this, we can mark this as a requirement. So for example, we can go here and say apply this countermeasure, which means that we will now have a new countermeasure or a new requirement here. It's currently not tracked on the issue tracker, so we can go and create a new ticket for it, and we will automatically have a new ticket that has been created on Jira on our issue tracker with all of the information that was in that initial ticket there. So as a security team, the first objective would be to review this model, check that it meets reality, so the auto generation that the tool performs is accurate, and that our risk response to it is what we want to do. So here we can see we have a single weakness, we have two countermeasures. One of those countermeasures mitigates the risk 50%. The other is a recommendation. So we're not actually planning to implement this, but we can see that it mitigates the risk a further 50%, which means that we have a planned mitigation for 50%, and we're going to leave 50% unmitigated. So as a security team, you can decide what you want to do with this risk. You may decide that certain risks are not worth mitigating, in which case you can accept the risk and provide a good reason for this. So cost high, likelihood low. This acceptance is audited and stored within the system, so we know exactly which user did it, why they did it, and what date. And you can do the same thing for threats that are not relevant to this model. So you can mark them as not applicable and provide a good reason about why are they not applicable, and they'll be removed from the model. They're not deleted, they're still available, they're just removed from all of the risk calculations and from the user interface. So the current risk rating is interesting because this is dynamically adjusted based on the status of our countermeasures. So if we have a look at an interesting countermeasure here, so here we have a high risk countermeasure, and we can see that we have a single requirement here. We have an issue linked to it, and it will mitigate 50% of the risk. If our implementation team, that's to say the developers or ops team, mark this ticket as implemented, so they mark it as done within their issue tracker, done, fixed, and done. So this ticket is closed. SRA will automatically sync with the issue tracker every 10 minutes in the background. Just to preempt that, I will choose to sync with the issue tracker here. And what we will see on the threat model is that our status has been updated. So we can see that not only did we plan to mitigate it, but 50% actually has been mitigated. We can see that our countermeasure progress has moved to 100% because we've done everything we planned to do. And our current risk rating has been reduced to medium because developers have implemented something, and therefore we understand that we've reduced our risk here. Of course, we're basing this decision purely on what the developers have told us they've implemented on their issue tracker. Ultimately, we want to verify this. If this is done through the QA team, they may want to go and check whether this countermeasure has been implemented, and they can associate a test result with that. If you're doing penetration testing, then they would more likely look for weaknesses. So they would identify vulnerabilities in the system, and they can use the threat model generated by SRA as a checklist for some of the things they need to test for. For example, if they test for this weakness, we have information about the weakness, they could record a test result. And they can say, this test has failed. They can provide some notes. So it's found vulnerability XYZ, and information about what they found, how they exploited it, and they could save that information there. The effect of this is that we mark this test result as a vulnerability. We propagate this up to the threat, and we highlight this in red because now we know we have a confirmed vulnerability here. Our countermeasure progress is still complete, but we increase our risk rating either back to its original or even to higher than its original because we now have a confirmed vulnerability in the system. So it's very clear that we're exposed to some risk here, and we can automatically create a new issue when we do the sync next, or we can manually go and create a new issue on the issue tracker for this vulnerability. If I click on create new issue here, we'll see that we have a new ticket created in the issue tracker. It includes the information about the vulnerability, references, as well as the tester's notes. So whatever the tester included in the information there will be linked here. We also automatically link to the countermeasures that are associated with this. So the key here is that this countermeasure, which was marked as implemented, has not actually been implemented, or perhaps it has been implemented, but there's been an error in the implementation. For whatever reason, we know that there's a vulnerability in the system. To complete the workflow, if the developers mark this as a test that has passed, so for example, they go and do a retest of this and mark this as test passed, they could update the information, all okay, all fixed, save that within the system, save it, we will mark this as a test passed. Our weakness tests have all passed, and we will reduce our risk back to the reduced value based on whatever the implementation and the mitigation percentage is. The next time we do a sync with the issue tracker, I'll just force it here. And when we go and view this ticket, we'll see that this ticket about the vulnerability has already automatically been closed, and we've automatically included a commentary from the from SRA, which says that this vulnerability has been fixed and addressed. So SRA effectively acts as a communication mechanism between what's going on in the security team and what is going on in the implementation team on the issue tracking systems. Of course, what this gives you from a management perspective is that you can see at a glance how are your applications doing in terms of their progress down the security lifecycle. So we can see that at a glance, comparing our entire portfolio of applications, we can see that we have a payment web application which started off with a high inherent risk. It had a very low projected risk, which means that the security team had marked many countermeasures as requirements in order to reduce the risk to a level of 22 out of 100. And where we are right now is at the same level as the inherent risk. So from this simple chart, we can see immediately that it's the implementation team who needs to implement the countermeasures in order to reduce them to the projected risk level. On other products, we can see something like our consumer banking web application. We started off with an inherent risk of 67, and we've made a tiny bit of progress to reduce that risk rating to 66, but the implementations team still has a ways to go to reduce that to a level of 38. We can then also look across our entire portfolio. We support different business units, so we can look across specific business units. We can sort threats based on their risk rating, based on their test failures, and so get a better view about what is going on across our entire application portfolio. A neat feature which is very useful, particularly if you have standardized deployments within the application, is to create templates for particular products. So, for example, if this consumer banking web app that we were designing as a threat model with its current status, some threats marked as risk accepted, others implemented, and so on, we could decide that this is in fact a template that we're going to reuse. And what we can do is publish this as a template. It will then be visible outside of the business unit of the current user. We can say that's fine. It disappears from the product view, but it now is available as a template for other users. So if I start a new product, let's call this Second Bank. When we start up the architecture questionnaire, we now have a new tab for templates, and we can just say we want to use that template. And we will import the threat model exactly as it was for that modeled application, and we can then reuse it. So this saves a huge amount of time if you have standardized components or standardized architectures that you keep repeating within the organization. So we can skip those, and we come back to our threat model, which is an identical copy of the previous one. Okay, some of the more advanced features are the rules engine. So the SRA platform is a really open platform. All of the questionnaires are editable. All of the content is editable. It's also exportable from the system. So you really can customize the system to best suit the needs that you have, and also to cater for the environments and the patterns that you're using within your organization. Okay, thank you very much. And back to you, Mark.
Thank you for that, Stephen. Hopefully now you've got a little bit of insight into the Secure by Default application, particularly managing through the generation of threat models and how we manage the requirements and countermeasures. There are other parts of this diagram which we haven't demonstrated due to time, but obviously we're happy to answer any questions that you've got that or more detailed information. So we can take questions if anybody has any questions. I think the one which has been asked the most, and we are running a bit short of time, is who else is using this? I think that's, we've got 7 people asking that. To be short on that one, we have 2 major European banks. We have an investment management organization, a global investment management organization, one of the world's biggest CRM systems, and other organizations similar to that. So these are people with high security requirements and vulnerabilities and value of data, and we're working closely with them on these apps. So hopefully that's a good answer for you. If you need any more information on who they actually are, obviously we'll be happy to talk in more detail later on. But thank you all very much for taking the time to view this webinar, and I'll leave you with some of our details at the back here to enable you to give us a call if you'd like to arrange a more detailed demonstration for your organization. Thank you all again, and we look forward to speaking with you again in the future.